What's up, everybody? This is Mr. Williams, and I'm coming at you today with another video. Today, we are talking about the discriminant, and I have a definition right here of how I would define the discriminant. It is the part of the quadratic formula that tells us how many solutions exist. So, in summary, basically, the discriminant just helps us predict what the solutions will be. It helps us predict what the solutions will look like. Okay, what solutions are you talking about? Great question. Glad you asked. I'm talking about the solutions to to a quadratic equation. So here we have a quadratic equation. They're going to be in this standard form right here. And if I ever wanted to solve for x, that means I'm looking for the solutions. The discriminant helps me predict what those solutions will look like. So the discriminant is not the solution itself. It helps us predict what the solution will look like. How do you do that? Well, all you have to do is substitute into this formula right here, b squared minus 4ac. Where does that come from? B squared minus 4ac, you can see it's right here. It comes from the quadratic formula itself. The quadratic formula is actually how we find the solutions. The discriminant is the part of it that helps us predict what the solution will be. So all you do is substitute into that, and you go by these three guidelines right here. If your discriminant is greater than 0, then there are two real solutions. I don't know what those solutions are yet because I haven't solved it. I'm just making my prediction. I don't know what the solutions are, but I know it's two of them, and they're real numbers. If the discriminant is less than 0, then there will be two imaginary solutions. I can expect x to have an I in one of the solutions, or both of them, really. And if d is equal to 0, there's one real solution. And sometimes it'll just be the same number, but it's still one solution. All right, so let's just jump right in here. Enough of the explanations and such. Let's just jump in. Look at a couple of examples. So here is our quadratic equation. It is in standard form, ax squared plus bx plus c equals 0. So first thing I want to do is label it. What's my a coefficient? A is going to be 5, b is positive 2, c is negative 3. So now I'm going to take my b squared minus 4 times a times c. That is the discriminant formula. All right. So all I have to do is substitute it. I know b is 2, so I'm going to take out the 2. We'll take out the b and put in a 2. I'm going to take out the a and put in a 5. I can do this quickly. And take out the c, and I'm going to put in a negative 3. That minus sign means that the 3 is negative. So put that in there. And we just use some simple arithmetic and we just multiply this out. So this is 4, and we have 4 times 5 is 20. 20 times negative 3 is negative 60. So it's like that. And of course, we've got these double negatives here, so that's going to become positive. So my answer is going to be 64. Now, my discriminant is 64. Q, go back to the equation. We're not saying that Q is 64. I still don't know what Q is. But this discriminant is going to help me predict what type of solution it is. So let me go back to my notes. Because I see that my discriminant is greater than 0, that means there are two real solutions to this. So that's what I can conclude. So whatever Q is, I know that it's going to be two real numbers. So I'm going to say two real solutions. Abbreviate that. Let's do one more. Matter of fact, let me just clear all of this. Let's try one more. All right, so let's do the second one. So A is going to be 3, B is negative 4, C is 1. So let's plug that in. We always do B squared minus 4AC. That's going to be your formula every time. And all you have to do is substitute into it. Take out the B, put in negative 4. Take out the A. I want to move a little faster here. Take out the A, put in a 3. Take out the C, put in a positive 1. Multiply that out. You got 16 minus 12, and that equals positive 4. So again, my discriminant, d equals 4, it's greater than 0. So I know that there are two real solutions. All right, that's all you have to do. You just substitute it. Let's take it up a notch. Say you get a problem like this. Let's look at number 15 right here. Let's look at this one. Now, I'm going to use the discriminant, but something's up. This problem doesn't look like the rest of them. That's because it's not in standard form. Standard form says that the equation has to equal 0. Well, it doesn't. It equals negative 7x minus 9. Well, if that's the case, we just have to make it equal 0. No big deal, right? So let's just make that equal 0. So to do that, I'm going to add 7x to both sides and put it over there. Now, I cannot combine this 7x. I can't combine it with the x squared because they're not like terms. I can't combine it with the negative 6 because it's also not a like term. So we just write all three of them. Bring everything down. Negative 6x squared 7x minus 6 equals negative 9. See that? Because the negative 9 is left. Now, I'm going to add 9 to both sides. When I add 9 to both sides, I've got 0 there. And I've added 9 right there because that's the only like term. Now this whole thing is going to become positive 3. There you go. Now it's in standard form. So I can do negative 6 is A, B is 7, and C is 3. Plug that in. I'm sorry, substitute that in. And you'll have 7 squared is 49 minus 4 times negative 6. Ooh, excuse my writing, y'all. Times 3. That's a negative. And you multiply all of that out. Really, you could just put this in your calculator to save some time here. So we've got 24 times 3, that's 49. 72, 49 minus 72 equals negative 23. So here I know that my discriminant is negative now. That's a 2. So go back to my notes. What does that mean if it's less than 0? Well, that means that there are two imaginary solutions. So that's what I'm going to write. So two imaginary solutions. Again, I don't know what the two imaginary solutions are. I don't know what the value of x is. I didn't solve it. I just used the discriminant to predict the solution. Again, discriminant is just a prediction. All right. Let's do one more for good measure. Say you've got, I don't know, I guess let's just do this one. Same thing. I see that it doesn't equal 0. It equals 8n. So I need to subtract 8n on both sides and combine it. I'm not going to combine it with 7n squared. They're not like terms. So I'm going to bring everything down. 7n squared minus 8n. Oh, I'm sorry. So that's 16 minus 8. So that's going to be positive 8n equals 0. Now, there's something up with this equation also. Let me start labeling it. I've got my A, I've got my B, but I don't see a C. 0 is not C. Well, it kind of is actually. So if you don't see a C term, if you don't see a constant, that means your C is going to be 0. So we know that, let's plug it into our formula. B squared minus 4AC. We know B is 8, so that's going to be 64. 8 squared, 64. Minus 4 times negative 7. Whoa, excuse my writing. Let's fix that. That's a 7. Now, C is 0. How do I know that C is 0? Because I don't have a C term. There's no C. So there's nothing there. It's a 0. Now this math becomes easy. All of this right here is going to be 0. Because anytime you multiply times 0, it's 0. So my discriminant is actually going to be 64. There we go. So just remember that your discriminant is a prediction of your solution, and have fun with this. Hit me up if you have any questions.